various multiverse theories
give it
over
a try
time.
anyway.
Prominent, the concept
the
of infinite
multiverse,
worlds is a very old
could
idea.
erode
Public
there could be
confidence in
pockets
science.
Logic inspired in
There's
part by the
not
inability
yet
of
any
experimental
experimental
evidence.
In the vastness of the cosmos, beyond the reaches of our understanding, lies a concept that has captured the imagination of scientists, philosophers, and storytellers alike. The multiverse. Everyone loves the idea of parallel universes. Maybe it's the appeal of an ideal world where you have second chances and things turn out differently. For decades, scientists have grappled with the idea that our universe might not be the only one. What if there were other universes parallel to our own, each with its own unique set of physical laws and constants? The scientific community, physicists who concern themselves with the very early universe, and cosmologists, thinks that the laws of physics as we experience them are set in the very earliest stages of the universe. And quantum fluctuations in everything would be responsible for another universe having slightly different laws of physics than ours. Because the quantum fluctuations will take it in a slightly different law of physics direction than our universe. And this would just keep going. Every universe that's born, even if it started out in the very first instant, a later instant when other laws of physics manifest, could be slightly different. The multiverse theory arises from our attempts to explain the fundamental mysteries of the cosmos, such as the nature of dark matter, the origin of the Big Bang, and the fine-tuning of the universe for life. One of the most intriguing aspects of the multiverse is the idea that every possible outcome of quantum events is realized in a different universe. This means that there could be universes where dinosaurs still roam the Earth, or where humans never evolved. With the multiverse, where there could be pockets of the universe that are expanding with no knowledge of any other pockets of the universe, and these are essentially independent universes from one another. And never the twain will meet in any reality. Imagine you're a ship at sea, and you look to the horizon and that's your whole universe. There to the horizon there's another ship that has its own horizon, and these ships don't even see each other. You'll only see each other if somehow your two horizons can overlap, and we don't know how to do that in our universe because they're non-causal. You'd have to find some way to tunnel from one universe to the other in order to access that, but that could be very dangerous because if the laws of physics are different than the ones you evolved on, then you could just dissolve into a pile of goo because the charge on the electron is different, and all of your biochemistry would change. The multiverse is a hypothetical group of multiple universes. Together, these universes comprise everything that exists, the entirety of space, time, matter, energy, information, and the physical laws and constants that describe them. The different universes within the multiverse are called parallel universes or alternate universes. Physicists, speaking informally, often say universe when they really mean observable universe, that is, the part of the whole universe that we've so far been able to see. And it's perfectly fine to talk about multiple different observable universes, for example. An alien near the edge of our observable universe will see parts of the whole universe that we can't yet see because the light hasn't had time to reach us yet. But that's a well-understood question and not what physicists normally talk about when they discuss multiple observable universes or multiverses. So let's cut to the chase. In physics, the word multiverse normally refers to one of three distinct and largely unrelated proposed physical models for the universe, none of which has been tested or confirmed by experiment, by the way. Let's take a look at the types of multiverse models and interpretations which have made in the past years. 1. The many worlds interpretation. In this interpretation of quantum mechanics, every quantum event causes a branching of the universe into multiple parallel realities, each representing one of the possible outcomes. For example, in the famous Schrödinger's cat thought experiment, the cat is both alive and dead in different branches of the universe. 2. Bubble multiverse. Proposed in the context of eternal inflation theory, this model suggests that our universe is just one of many bubble universes that spontaneously form and expand within a larger, continuously inflating space. Each bubble universe may have different physical constants and laws of physics. 3. String theory landscape. According to string theory, the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings. The theory suggests that there are a vast number of possible configurations for these strings, leading to a landscape of different universes with varying properties. 4. Brain multiverse. This model is based on the idea of extra dimensions beyond the familiar 3 spatial dimensions and 1 time dimension. In some versions, our universe is a membrane or brain floating in a higher dimensional space, and other brains could exist parallel to ours, each representing a separate universe. 5. Parallel universes in cosmology. Some cosmological models, such as the cyclic universe theory, suggest that our universe undergoes cycles of expansion and contraction. In this scenario, each cycle could produce a new universe with potentially different properties, leading to a multitude of parallel universes. 6. Quantum multiverse. Beyond the many worlds interpretation, there are other interpretations of quantum mechanics that propose the existence of multiple universes. For example, the many minds interpretation suggests that every possible observation outcome corresponds to the existence of a separate universe in which that outcome is observed. 7. The ultimate mathematical universe hypothesis. This is Tegmark's own hypothesis. This level considers all universes to be equally real, which can be described by different mathematical structures. Tegmark remarks that abstract mathematics is so general that any theory of everything, which is definable in purely formal terms, independent of vague human terminology, is also a mathematical structure. He argues this implies that any conceivable parallel universe theory can be described at level 4 and subsumes all other ensembles. Therefore, this level brings closure to the hierarchy of multiverses, and there cannot be a level 5. The American theoretical physicist Brian Greene discussed 9 types of multiverses, but we will discuss them in another video. These are just a few examples of the various multiverse models proposed by physicists and cosmologists. Each model offers a different perspective on the nature of reality and the possibility of parallel universes. A philosopher once said, "The multiverse challenges our notions of identity, causality, and free will. If there are infinite versions of ourselves in parallel universes, what does it mean to be me? Do we have any control over our destiny, or are we just actors in an infinite cosmic drama?" As we gaze up at the stars, we are reminded of the boundless possibilities that lie beyond our understanding. The multiverse beckons us to explore, to question, and to imagine what other worlds might exist beyond our own.